Right, so welcome to this lesson. We are going to be looking at the properties of probability and solve some exam questions. Okay, so last time when we are looking at probability, we discussed the introduction to probability. We learned what an experiment is, we learned what a trial is, what an outcome is. We discussed the set of all the possible outcomes, okay, which we called as the sample space. And then we also discussed an event. Okay, so we said an event is just a subset of the what? Of the sample space. So if you didn't watch those videos, they're there on my YouTube channel. You can access them from there, or you can also access them on our website. All right, so today we continue with the properties of what? Probability. Okay, so I'm going to start with the first one, which is the most common one. So let S, okay, let S be a sample space. Okay, be a sample space. And then let A be an event. Okay, so from this statement, we can get a lot of properties for probability. Okay, so the probability of the event A, so this is the first property. The probability of the event A, okay, is always between 0 and 1. It can never go beyond those two extremities, okay? It's always between 0 and 1. So you can say that this probability here is always between, okay, 0 and what? 1. So that's the situation that we have there. The probability of an event from a sample space, okay, is always between 0 and 1. And then the probability of the whole sample space, okay, the probability of the whole sample space is always equals to what? 1. Okay. And then let's say that in this sample space, maybe we had a lot of events, okay, that were a part of this subset. Okay, so it means that when you get the summation of all the probabilities of those events that are coming from that same sample space, okay, if you add all their probabilities, it's going to be what? It's going to be equals to 1. Okay, so meaning, for example, if from this sample space S, okay, we had the event A, we also had another event B, we also had another event C, okay, so it will mean that the probability of the event A plus the probability of the event B plus the probability of the event C, okay, should always add up, okay, to the probability of the whole sample space, which is 1. So the probabilities of all these uh, events, which are subsets of this sample space, okay, they should always give you what? 1. Right, so these are the first two important properties that you must know about probability, okay? And then from there, we can talk about another property, okay, which is a property which involves mutually exclusive what? Events. So if you have any questions, you're free to just unmute yourself and ask. Okay, so this property, okay, says that if event A and B, okay, are mutually exclusive, okay, if event A and B are mutually exclusive, then what does this mean? Okay, this means that the probability, okay, of A intersection B will just be equals to what? 0. Okay, so this simply means that there are no common, okay, there are no common events occurring between this A and what? And this B. Okay, so if A and B are mutually exclusive, then it simply means that their intersection, okay, the probability of their intersection is 0. That's what it means. All right, and then using this property for mutually exclusive events, okay, we can also add it to the part where we are finding the probability of a union, okay, of two events, okay. So let me just erase this. So if you're finding the probability of the union of two events, for example, probability of the event A union B, okay, what you should get here is the probability of A and then plus the probability of B, and then you say minus the probability of their what? Intersection. Okay, so this is one of the properties for the union of the events A and B. Okay, so if you have two events and then you want to get the union of those events, you just say the probability of A union B is actually a probability of A plus probability of B minus the probability of A intersection B. Okay, so this becomes interesting if those events are mutually exclusive. Okay, so remember we said if they are mutually exclusive, then probability of A intersection B is what? 0. Okay, so it means this formula here for the union of events, okay, if you're dealing with mutually exclusive events, then it's going to change, okay, because this part here will just be 0. Okay, that part will just be 0. So if two events, okay, are mutually exclusive, and then we want to find their union. Okay, we are going to say the probability of A union B will just be equals to what? The probability of A plus the probability of what? B. So note that you can only use this one here. Okay, you can only use this one if your events A and B are mutually exclusive. So if they are not mutually exclusive, then you have to use this formula here on top. Okay, you have to use that formula on top. But if they are mutually exclusive, then it means you can use this one down here because this part here becomes 0 and you'll not need it in your calculations. Okay, so be careful of this property here. Sometimes they can ask you to actually prove this one here. Okay, so you need to learn how to prove this one here. So the proof is there in Dr. Nawa's notes. I don't know if you guys have it. Okay, if you don't have it, you can just inbox me after the class. I'll send you. So you have to pass through this, the proof of this part here. All right. So I've explained what I wanted to explain there, and then we can look at the complement of events. Okay, so a very important property. Okay, because when you are given to find probabilities of complex situations, okay, what comes to your rescue is the property of what? Complement of events. Okay, so we know from our set theory that if I have set A here, okay, and then I have another set A complement, okay, then this complement here will just contain all the elements that are not in A, but they are part of the what? Of the universal set, right? Okay, so we get that same concept and then we apply probability to it. Okay, so if A, okay, is an event, if A is an event, okay, and A complement, okay, is its complement, okay, then the probability of the A complement will just simply be equals to 1 minus the probability of the event A. Okay, so meaning that in other ways here we are saying the probability of A plus the probability of A complement should always give you what? 1. Okay, the probability of A with its complement, you add with the probability of its complement should always give you 1. But the most common form in which they give this formula here is in this form like that. Okay, so the probability of A complement is equals to 1 minus the probability of what? A. So guys, know how to use this formula here. Okay, know how to use this formula. It's going to save you a lot when you're dealing with complex probability questions. Okay, so take note of that formula there. All right, and then what other properties can I talk about? Okay, so let me talk about this property. So I'll need to draw a Venn diagram for you to understand. Okay, so the other property that I want to talk about, it confuses a lot of people, is that the probability, okay, the probability of A complement intersection B, okay, is the same as, okay, is the same as the probability of B and then minus the probability of A intersection B. Okay, so you have to know this property here, and I'll explain it using a Venn diagram. Okay, so if, for example, I have this Venn diagram here, okay, I have this Venn diagram here that contains set A there, okay, and then I also have set B there, okay, and then these guys are in this kind of universal set like that. Okay, universal set. Okay, so the probability, okay, of A complement intersection B will be in which region if we shaded it. Okay, so A complement is everything that is as outside A. So A complement is everything that is as outside A. So here where I'm shading with the blue here, all this part here is what? Not outside there, but just within the box. So all this part here, as long as it's outside A there, but within the box here, we're going to say that part there that I've shaded in blue is what? A complement. And then let's shade the part B with green color. So the part B will be everything that is inside this circle with what? With a red there, with a red line around it like this. Okay, so now where is the A complement, okay, intersecting the B? So the A complement and the B are intersecting on this part here where I'll trace in white. So this part here, okay, that part there that I've traced in white. That's the part where you have your A complement intersecting B complement, okay? So from this diagram here, we can see that this part here that I've traced in white, this part there, is just A complement intersection what? B. Okay. And then this part here, just this part here. What color should I use there? Okay, let me use maybe blue. So this part here, that part there on the middle there, where the A and the B are intersecting, we see that that part there is what? Is A intersection B. Okay, and then this whole set here that was in red, originally in red there, I should get this small. So this part here, all this part here was the set what? Was the set B. Okay, that part there was the set B. I should maybe use a different color. So let's get yellow. So all this part here, we're saying that was the set what? B. So if we want to find the probability of A complement intersection B, it is the same as, okay, subtracting the probability of this intersection here, okay, of this A intersection B from the probability of all this set B. Okay, so we see that from this whole set, which is B, and then you subtract a part like that. So you remain with this part here. So this part is the one that we said was A complement intersection B. So that's where this property here comes from. Okay, so if you have any question, please ask because you're going to be using this property. Okay, so it means that the probability of A complement intersection B.
I have a question.
Okay, you can ask.
Yes. So can it be proven without using a Venn diagram?
Without using a Venn diagram? No, you have to visualize it. Yeah,
Okay.
you have to
Okay.
see it.
So they can't ask us to prove without using a Venn diagram.
No, they will ask you to prove, and then you show the diagram in the proof.
Oh, okay.
Yes.
Thank you.
All right. Yeah, so this same part here is also included in the proving of this property that I said, probability of A union B, okay, is equals to the probability of A plus the probability of B, and then you say minus the probability of A intersection B, okay? So this same part here that I was showing you is also used in the proof for this guy here. And it can also come like on its own like that as a question. Okay, so take note of it and then understand it because it's going to come. All right. Okay, so those are the properties, okay, of probability that we are going to be using, okay, today as we solve some of the questions that I've picked. So I've just picked simple questions so that you guys get to understand these properties, okay? And then later on as we move throughout this course, we'll be introducing all those complex questions, we'll be solving them together, okay? But today, I just wanted to introduce the properties and then we solve just simple questions so that the concept can sink in, okay? So that when we start the complex one, no one is left what? Left behind. Okay, so let's solve the questions together. So I have some series of questions here. I think there are about 4. We're going to solve them together. So this is the first one here. Okay, so the first one there, they're saying events, if A and B are mutually exclusive events, and the probability of A is 0.2, while the probability of B is 0.3, find the probability of A complement, B complement, A union B. This should be A intersection B, not A union B here. And then here we have probability of A complement intersection B complement. Okay, so we've been given that the probability of A is simply 0.2. Probability of B is 0.3. So these are very simple questions, okay? You don't even have to think here. So A, we are saying the probability of A complement. So probability of A complement is 1 minus the probability of what? A. That's what we said from the properties, right? So this is just going to be 1 minus 0.2. So what will this give us? It will give us 0.8. Okay, and then the next one, we still use the same property. The probability of B complement will just be equals to 1 minus the probability of what? B. So this is going to be 1 minus the probability of B is 0.3. So this is going to be like 0.7. Right, so here we've just used the complement rule or the complement property in order to find the probability of A complement and B complement. And then on C, we have the probability of A union B. Okay, so the probability of A union B, what did we say it is? Okay, we said the probability of A union B is probability of A plus probability of B and then minus probability of A intersection B. But here we are told that what? These events are mutually exclusive events. Okay, so if they're mutually exclusive, then probability of A intersection B will just be what? 0. Okay, so this part here becomes 0. So it means here we're just going to add the probability of A, 0.2, plus the probability of B, which is 0.3, and then minus 0. So this is going to give us what? 0.5. Okay, and then the next one here was supposed to be A, and then here intersect B. So probability of A intersect B, because they have said they are mutually exclusive events, we're just going to say it's what? 0. Okay, so probability, you have to take note of the language. Okay, so it differs from the math that we are used at first year, because at first year, most of the things were just mathematical. They won't ask you for concepts. You just solve and then you find the answer. But here, you can't solve without knowing the concept. Okay, so you have to read those definitions that they give you. You understand the definitions and then you apply them in the questions. Okay, that's how we are going to move. So if you can't understand the definition, then you can't apply it, and then you won't be able to solve any question. Okay, so make sure you understand the what? The definitions. They are very important. Okay, so let's take a look at the last question there. So the last question involves some first year thing. Okay, so the probability of A complement intersection B complement. Okay, so from the first year De Morgan's laws, what did we say A intersection B complement was? Okay, so from first year, we know that A complement intersection B complement is the same as A union B, and then we write the complement outside, right? So here I'm going to say this is the same as the probability of, and then this guy here has changed to this by the De Morgan's laws. So it means we have A union B and then complement. Okay, so immediately we introduce the complement there, it means we can easily find our answer. Okay, so there it will mean that we have 1 minus the probability of what? A union B. So we've used the complement rule here, and we know the value of this because we are just from finding it. We found this here was 0.5. Okay, so it means here the probability of A complement intersection B complement will be 1 minus 0.5. Okay, so this will just give us 0.5 as well. So this one here is our answer there. So any questions there on number one? Yeah, so these are very straightforward. So we start with the very simple ones, and then we go on and have the harder ones. All right, so we go to question 2, which is this one here. So question 2, what are they saying? Okay, so question 2, they're saying let the probability of A equal the probability of B, which is 1 over 3, and then the probability of A intersection B is equals to 1 over 10. Find the following. Okay, so the following, we are starting with A union B. Okay, so here they have not mentioned anything about mutually exclusive events. So you assume that they are not mutually exclusive. Okay, unless they mention. So it means that A, we're going to use the formula for the union of events. So union of events is the same as probability of A plus the probability of B minus the probability of A and then intersection B. So we have all these values. Okay, so here I'm supposed to write A there, right? So this one should be A there, like that. Okay, so the probability of A and B, we are told they are equal. Okay, so we can say 2 multiplied by 1 over what? 3. So this is the same as 1 over 3 plus 1 over 3. And then minus the probability of A intersection B, which is 1 over what? 10. So this is going to give us what? Okay, so this will be 2 multiplied by 1. That will be 2 over 3. And then minus 1 divided by 10. We look for a common denominator between this 10 and 3. Okay, so the common denominator here will be like 30. So 3 into 30, it's 10. 10 multiplied by 2 to be 20 minus 10 into 30 is 3, multiplied by 1 to be 3. So it means the answer here will just be 17 over 20. Okay, to be 17 over 20 there. So uh, that will be our answer there. Okay, and then let's look at the one on B. Okay, so the one on B, we have this. We have P, A complement, and then intersection B. Okay, so this one here, okay, was that property that I mentioned. So we must use that property that I mentioned there. So A complement, okay, intersection B is the same as what? So if it's confusing to see, you just draw up a Venn diagram here. Okay, so you have your A there, and then you have your B. So A complement is everything that is outside this set A. And then B is everything that is here. So it means the A complement intersection B is this part here that I'm shading. This part here. Okay. So how do we find the probability of this part here that I've shaded? Okay. You just say the probability of B, okay, and then minus the probability of what? Okay. Minus the probability of minus the probability of this part here, which is A intersection B. So you're going to say A intersection B. Okay. So sometimes just draw up a picture to visualize whatever you want to find. Okay. If you don't draw a picture, it will be very hard for you to know what you're finding. Okay. So from this picture now, we can see that the probability of B is there as 1 over 3, and then minus the probability of A intersection B, which is just 1 over 10. Okay, so we can subtract those two. So this is going to be 30, 10, 10, okay, minus 3, 3. Okay, so this will be 7 over 30. Right, so this will be the probability. Okay. Any questions there before we go to C? Okay, let's look at C then. So C, we have a complement and then a union there. So it will be very wise for us to draw a diagram so that we just visualize what we want to find. So we want to find the probability of A union B complement. Okay. So this probability here means what? It means you are getting what you have in A, okay, and then you are subtracting. I mean, we are combining what the probability of the elements that are in A with the probability of what we have outside B. So maybe we come up with a sketch here. So if this is our Venn diagram, let's see if we'll be able to visualize it. And then I have A there, and then B there. Okay, so B complement, okay, B complement will be everything that will be outside this B here, everything that will be outside this B. And then A will be this part here. So let me share it. So the set A is this one. This is the set A, okay? And then the B complement is everywhere here outside. So we can shade with red lines like that, like that. Everything that is outside B. So including this part. Okay, like that, like that. So we are finding the probability of everywhere where it's shaded. Okay, we are finding the probability of everywhere where it's what? It's shaded. So which part is shaded in this diagram? Or let me say, which part is not shaded? Can we describe the part that is not shaded in this diagram? Anyone to try? Can you describe the part that is not shaded in this diagram? Hello, come on, guys. Can we describe the part that is not shaded? This part here that has remained black, this part here. Can we describe it using set notation? If we describe it using set notation, what is it going to be? Okay, so this part here, okay, I should use a different color. So this part here, the one that is not shaded here, okay, it's the part that we said was A complement intersection what? B. That was the part, okay? So it means here, since we are finding the probability of the shaded part there, okay, we are just finding the probability of 1 minus the probability of this guy, which is not shaded, okay? To find the probability of everywhere where it's shaded here, whether it's a red line, it's a blue line, okay? To find the probability of that shaded part, we just say 1 minus the probability of this part that is not shaded, okay? And we are from finding the probability of this. What did we find the probability of this was? Okay, we found the probability of that was just 7 over what? 30. So to find the probability now of the part where it's shaded here, either red or blue, we are going to say 1 minus the probability of this part which is not shaded. Okay, so it's very important to picture your events like that. Okay, it will be very easy for you to get your probability. If you can't picture it, then it will be very hard for you. Okay, so that's what we are getting here. So we are going to say this here is the same as probability of 1 minus this is the probability where it's not shaded, which we found was 7 over what? 30. So 7 over 30 like that. So you can subtract those. What are you going to get as your probability? I'm going to get 23 divided by what? 30. So this is the probability of this guy here. All right, so any questions there? Any questions there? All right, so if there are no questions, let's solve the last one then on this question 2. Then we can go to question 3. Okay, so it's very important for you to picture whatever you are doing. So if you picture it, it will be very easy for you to find it. So now we are on D. So D, they're saying the probability of A complement union B complement. So here we are also going to use the De Morgan's laws. Okay, so this will be the probability of A intersection B and then complement. Okay, so how do we find the probability of a complement? We say 1 minus the probability of the same A intersection what? B. All right, so this will be equals to 1 minus, what is the probability of A intersection B? 1 over what? 10. So 1 minus 1 over 10 is going to give me 9 over what? 10. So this is the probability of A complement union what? B complement. All right, so you have to know this, okay? So this is just coming from De Morgan's law. Those who are doing real analysis, you guys were, I'm sure you've already proved this in class, the De Morgan's laws, okay? So make sure you study the notes of that man, Dr. Muzundu. Dr. Muzundu doesn't bring anything apart from what is in his notes. So don't even try ataweti and the past paper wala. Just study what is in his notes. That's the same thing that is going to come. All right, and then question 3. Okay, question 3 now we have been given 3 events. So let's try to find the probability if we are given 3 events. Okay, so the rules that we should follow are similar. Okay, so here they're saying the probability of A is 1/2, probability of B is 1/8, probability of 4 is probability of C is 1/4, where A, B, and C are mutually exclusive events. Okay, so the first one they're saying find the probability of, okay, so this is A, find the probability of A union B and then union C. Okay, so they have said these events are what? Mutually exclusive. Okay, so if the events are mutually exclusive, then their intersection does not count. Okay, their intersection is just what? 0. So it means the probability of this is just adding the probability of A plus the probability of B and then plus the probability of what? C. That's how we are going to find this, because they have said the events are what? Are mutually exclusive. But if the events were not mutually exclusive, then we are going to handle it in a different way. Right, so the probability of A is 1/2 plus the probability of B, which is 1/8, plus the probability of C, which is 1/4. So this is going to give us what? Okay, so you can say the common denominator here will be 8. So 2 there, it will be 4 multiplied by 1, it will be 4 plus. Here to be 1, 1. Okay, this will just be 1 plus 4 into there, it will be 2. Okay, this will be 2. This will be equals to 4 plus 1 plus 2. That will be 7/8. So that's the probability of A, union B, union what? C. Okay, and then the other one, we're just going to use the De Morgan's laws there. So B, the same, find the probability of A complement intersection B complement intersection C complement. Okay, so those who are doing real analysis, you're going to do like the De Morgan's laws for a family of sets. Okay, so here we only have 3, but you guys are going to go to infinity, an infinite number of sets. You're just finding their intersection. So you're going to encounter that. Okay, but how do you do this? Okay, so you apply the De Morgan's law. So the De Morgan's law still work even if you have more than 2 sets. Okay, if you have 3, 4, 5, an infinite number of sets, they will still work. So here what we are going to say is that this here is the same as the probability of, and then we are going to apply the De Morgan's laws here. So it will just be A union B union C and then complement outside. For those who are wondering what is happening, okay, it's simple. We are just distributing this complement to everything that is inside. So if we take this complement to the A, we end up with A complement. We take the complement to the union, we end up with the intersection. We take the complement to the B, it's B complement. Okay, so that's what is happening. And then here, okay, we have the probability of a complement of the event. Okay, so it means here it's just going to be equals to 1 minus the probability of A intersection, union, not intersection. So A union B and then union what? C. And we already have the value for A union B union C. So this is 1 minus 7/8. Okay, so it means the answer here will just be 1 over what? 8. So 1/8 will be the answer there. All right, so any questions there? Okay, no questions. So let's look at the last question here. Okay, so the last question, which is C, it's a similar culprit, that one. So we have A intersection B complement. Okay, so this one, just draw the diagram like this, Venn diagram. Okay, so we have set A and then set B there. So this is set B and then A. So here we are saying A intersection B complement. Okay, so where is A intersection B complement? A intersection B complement, it's this part here. Okay, this part here, that's where A intersection B complement is. Okay, so how can we easily find the probability of this part that I've shaded? Okay, we're just going to say the probability, okay, of this whole set A minus the probability of this part here, which is the intersection of the intersection with the B. So we're going to say this here is the same as the probability of A, and then minus the probability of A intersection what? B. All right, so this is going to be equals to probability of A 1 over 2 minus the probability of A intersection B. Okay, so remember, okay, what we said. These events are mutually exclusive. So it means their probability for the intersection is just 0. So probability of A intersection B will be 0. So it means the answer here will just be what? 2. Okay, so you see that if you do not know the language, you can't solve. Okay, if you do not know the language, you can't solve. So you need to understand the concept, you understand the language, and then you'll be able to solve any question. Right, so any questions there before we go to question 4? I think question 4 will be the last question for today. All right, so let's go to question 4. So question 4, we have this question here. It's a bit of practical, so you'd have to really understand it. Okay, so question 4, they're saying, okay, the probability that a new airport gets an award for its design is 0.16. The probability that it gets an award for efficient use of materials is 0.24, and the probability that it gets both, okay, an award for design and an award for efficient use of materials is just 0.11. Okay, find the probability that it gets. Okay, so A, okay, A, they're saying the probability that at least one of the two awards is gotten. Okay, and then B, they're saying only one of the two awards. Then C, they're saying none of the two awards. So all these questions that they have asked here are different scenarios, okay, and we handle them differently. So depending on the language that is there. So you see why I was saying understand the language. So this one here on the first one, they're saying, okay, they're saying at least one of the two awards. So what does at least one of the two awards mean? Okay, it means this person, okay, it means this person can get the award, okay, for the design only, or he can get the award for the efficient use of materials only. Okay, that's what it means, at least one of the awards. So it can get the award for the design, or you can get the award for the what? For the efficiency. So it means that language there is just telling us to unionize these events, okay, for the design and for the effective use of what? The materials. So we're going to say, let the event of getting a design award be P. Let me use other. Okay, let the event of getting an award for design be N. Okay, so this one, design award. Okay, and then let M be the event of getting an award for efficient use. Okay, so when they say the probability of at least one of the two awards, they just simply mean the probability of N union what? M. So what did we say the probability of union is given by? We said a probability of the first set, which is N, plus the probability of M, and then minus the probability of the what? Of their intersection. Because these two have an intersection. They're not mutually exclusive. So N and then intersection what? M. So this is what we are going to have. Okay, this is what we're going to have. So the probability of getting an award for the design is 0.16, plus the probability of efficient use of materials is 0.24, then minus the probability for both, we are told it's what? 0.11. So this is what we have, right? Okay, so just get your calculator, punch in that value. Okay, you are going to get what? So let me punch this. Okay, so it's giving me 0.29. So this 0.29 will be the probability of getting at least one of the two awards. All right, so if you have any questions, please ask. All right, and then let's go to B now. So B, it also has a totally different language. Okay, so on B, they're saying, what is the probability, okay, that this new airport gets only one of the two awards? Okay, so this B is totally different from the question A. Question A, they said at least one. So you can get that award, you can also get that award. But here it means that when you get an award for the design, it means you have not gotten the award for the efficient use. And if you've gotten the award for the efficient use, it means you've not gotten the award for the what? For the design. That's what B means. Okay, so we are going to say the probability, okay, that only one of the two awards, okay, is going to be equals to. So this probability here is going to be equals to the probability of getting N, okay, intersection the probability of not getting M. And then we're going to say plus the probability of not getting N intersection the probability of getting what? M. Okay, so remember we said N was for the design and then M was for the effective use. Okay, because why are we doing this here? Because they said only one of the two awards. So if meaning that if I get the award for the design, I don't have to get the award for the effective use. And here, if I don't get the award for the design, it means I have to get the award for the what? For the effective use. Okay. And then what we have here was that property that I told you. Okay. Was that property that I told you about. Okay. So this one here is the same as the probability of A. Yeah, at A now. The probability of N. Okay. Same as the probability of N and then minus the probability of N intersection what? M. So only this part here is the same as this. Okay, and then I'm going to say that part plus the probability of this part here now. So the probability of this part, if you draw like a Venn diagram, okay, you are going to find that that probability is just the probability of M and then minus the probability of N intersection what? M. So what we're going to have is equals to probability of N plus the probability of M. And then this part and this part, we see that they are the same. So we're going to combine them. So they're going to become minus 2 probability of N intersection what? M, like that. All right, so what is the probability of N, which is getting the award for the design? It's 0.16 plus the probability of effective or efficient use, that is 0.24, and then minus 2, and then the probability now, which is the intersection, which is just 0.11, like that. Okay, so just get this value and then you punch it on your calculator to come up with the answer there. So, okay, let me punch this. Okay, so I'm getting 0.18. Okay, as my probability of only one of the two awards. Okay, so that's how we answer B there. So any questions there? Okay, no questions. Let's solve the last question. So the last question now, uh, okay, so the last question, they're saying, what is the probability that none, okay, that this new airport gets none of the two awards? Okay, so none of the two awards, it simply means we are finding the probability, okay, of the complement of the union of these two sets. Okay, we are finding the complement of the union of these two sets. So we are going to say probability, okay, that none of the awards is just equals to the probability of N union M and then complement. Okay, because it's none, so neither of them. And then this is the complement rule. So we are going to say this is the same as 1 minus the probability of N, then union M, like that. Okay, so this is going to be 1 minus. What did we find the probability of N union M was? Okay, so we found that it was 0.0 0.29, yeah. So 0.29. So you just subtract this in order to find the probability that they got none of their words. So 1 minus 0.29 is giving me 0.71. Okay, so this here will be our answer for this last question there. All right, so any questions there? So those are the questions that I wanted us to solve on the properties. Okay, so these are very simple questions, and then next time we'll go a bit deeper like that. So any questions there, guys? Right, so if there are no questions, thank you so much for attending the lessons. So the free classes continue this week. And for those who want to register, you can register using our website. Okay, just search Discrete Learning Institute on, discretelearning.com on Google Chrome, and then you should be able to come up and then you can register. All right, so have a blessed night.